Welcome to Taxonomy Online Mathematics. In this episode, we want to revisit the topic trigonometry once again. We've done it, I think, in some 3 years ago. There's a video, but as we are going by, there should be some changes to the videos we have recorded in each of the tutorials. So basically, we are just going to talk about things that surround trigonometry. I mean, this first episode, the concept behind some applications or areas where trigonometric functions or principles are employed. Now, when it comes to trigonometry, it is just a branch of mathematics that deals with the study that deals basically on the study of the relationship between the length and the angles of a triangle. The length, the relationship between the length and the angles, how the angles and the length relate with each other. That is basically what trigonometry is all about. Then it is coming from the Greek word trigonon. Trigonon simply means triangle, then metron, which means measure. So in your own small way, you can say that trigonometry is the measure of triangles. And triangle has sides and what angle. So that basically gives you that. Now, questions are asked most of the times when we are learning mathematics. What are the benefits of learning a specific topic? There are so many benefits of learning a lot of specific topics. Sometimes we ignore to give the details. But if you are somebody who is not into engineering, you might not see this as appreciative. You are in the market dealing with your normal calculation. What do you need trigonometry for? Good. The question is you are not going to be in the market in the open space. You are going to be there in a structure. You will not think of how the structure is what raised. Yours is I am going to the market and sell. The person who thinks about the structure doesn't just goes in there and conjure the structure. They make use of the mathematics, which you don't want to appreciate, trigonometry. Do you get it? So in this case, let me begin with the surveying, since I mentioned market structure. Surveyors, to do survey, what do? They make use of trigonometric principles. A lot of trigonometric principles are being employed in surveying the topography of the land, to know where to put the structures and to think of the calculations of plans that are done, how they can be able to make the plan for you that the structure will last for a longer period. Survey make use of principles of trigonometry. Then let's come back to the beginning. The navigation. I know sometimes when you are stranded, you just go straight forward to your the map. Then you key in where you want to go. Then you are being directed to go there. You say, oh, maybe I don't need mathematics for that. You just key in and leave it. The work that is being done, the coding that was done, it was done with the principles of trigonometry in order to direct you based on your GPA, the global position place that you are. Is it GPS, right? Not GPA. The GPS, where you are going. Principles of trigonometry are applied. The angles, how we can be able to find the easiest route to get to where you are going. That's an example of that. Then engineering, which is being a process of this also. After survey, the engineering, construction of road, building bridges. Yours is to be in the car and go, right? But engineering, we have what they call electrical engineering. We also have chemical engineering and mechanical engineering. In mechanical engineering, some motions in the car that you are boarding, which you will think of no mathematics. You wake up, as for me, I don't like mathematics. You just enter the car and go. There are some motions calculations, the facet areas, how some areas relate with each other, have principles of trigonometry. So if nobody think of these processes, it will still be in the stone age, where we still ride over the back of animals. You can see where I'm trying to go. There's principles that are employed to make life easier for those of us who hate the mathematics or who doesn't want to hear anything about mathematics, these principles are employed to make life easy for you and I. Then medicine. Now when you are sick, you go to the hospital, sometimes severe. They say, let's go and do CT scan. They're going to scan your system. MR, right? MRI. Those who are in the medical field can help us. Is it MRI, right? To take a scan of your system where they're able to see what the problem is. There is a principle of trigonometry which is applied in using the CT scan before they can be able to diagnose you who hate mathematics. There is a principle in that. Maybe the doctor in there making use of the scan also doesn't apply any mathematics. But the person who manufactured the CT scan have to apply the mathematics inside to help the doctor to be able to use it to help you so that you can be healed or cured from your illness. You can see where the story is. If you don't like mathematics, you don't have to say that what at all am I using mathematics for. You can decide to hate mathematics. If all of us do, then remember, life is going to be what? Unbearable. Because even without the mathematics, where you are watching me on your phone, TV, wherever you are, you may not be able to see me because it is made possible by algorithm mathematics. Musical theory, right? You have been listening to music. You don't know that what math is applied in the construction of an instrument. No, you don't know that without mathematics, those instruments that give you the melody that you have been dancing to, you won't get it. Then astronomy, that we also deal with what? The space, where sometimes we can be there and see that the distance between the stars and the planet is this. I can be able to have some fair knowledge about how many planets we have, the distance between this and this. This fair knowledge we are having was not just by coincidence. It was based on by astronomy, which applies some principles of mathematics and physics. All this that I'm trying to say is that trigonometry is applied keenly in some field in science and ICT, which help us to make life very, very, very easy for you and I. So remember, you might be good in swimming. Doesn't mean that those who are playing football are wasting their time. You might be good in what? Browsing, which without the computer, you may not go there. So there are so many things that you may not like, but are helping others to help you to like what you are liking. I guess that is clear. So these are all about the concept of what? Trigonometry. A bit lengthy, but I'm sure you will get one or two things from it. Then we proceed to find what we call basic trigonometric what? Ratios and their reciprocal. So basically there are two things involved here. The basic trigonometric ratios. Then their reciprocal. That's the second aspect. To find the reciprocal of those basic ones. Now when we talk of ratio, in this case, it is a comparison between two things. But we are referring to triangles. So it is the comparison between the side of a triangle, the length and size of a triangle. And this triangle we are referring to is only right angle triangle. So if I have a triangle, this is a right angle triangle which has three sides. I have A, B, C. How many angles have you seen there? There are three angles. One of those angles to be 90 degrees, which we are having. So it also means that I can also have this triangle here, X, Y, what? Z. These are also triangles, which are right angle. Now, if the angles are three, we can see them. These two angles need to be found. These two angles. So the ratio or the relationship between the side length, which are A, B, C, X, Y, Z, and the angles. So we need to have one or two angles indicated. So let's say if I have indicated this angle here, let me indicate the angle alpha here. The moment angle is introduced, then it adds meaning to the size of the triangles. I can easily find the meaning of the size. What I mean by meaning of the size, as the angle is introduced here, I can see that this angle is facing one of the sides. Is facing this side, and this also is facing this side. It's by coincidence that I'm seeing the two sides looking at the perpendicular or vertical. But let's see. Now, where it is facing is what we call the opposite side. So B and Y is called the opposite side. Or let's add a side. The opposite side of these two triangles. The opposite side, where the side facing the angle. Then the side facing the right angle box. We can see that this is a right angle box. This is a right angle box. And this right angle box is facing the side. And that side is obvious. It's the longest side. If you look at it from here to here, not drawn to scale, but you can see that this length is longer than the B and A, not combined, individually. C is longer than A and B. Z is longer than Y and what, X. That is the longest side. So the longest side also has a name. So it is going to be C equals to Z, which is the hypotenuse. Let me say hypotenuse side or hypotenuse leg. So the moment I'm able to identify the opposite and identify the hypotenuse, the remaining one is adjacent. So you can see that the adjacent side is always perpendicular to the opposite. This is the opposite, adjacent. You see that they are perpendicular, meaning they form the right angle. This is also the opposite, remaining one adjacent. So I can say that my A is equals to the X, which is also equals to the adjacent. So these are the various definitions we can give to the side. No matter how it is drawn, we need the opposite side. The moment the angle shifts from here to this place, A now become the opposite. I'm not saying that anytime a triangle is drawn this way, the side here is always the opposite. No. It is opposite in relation to the angle. So where the angle is facing, so wherever the angle is facing becomes the opposite side to the angle. The longer side always remains the same. If I draw any triangle in this form, no matter where the angles are placed, it is always going to be the hypotenuse, the longer side. The same thing in there. So let's see if I redraw this and have this here and have the angle here. You can see this is facing here. So if I'm going to pick all the A, B, C, D here, this is going to be, is facing here. So I will be having the B as opposite. The longer side here is this one facing here. So C, the hypotenuse. Then the one that is perpendicular to the opposite is the adjacent, which is the A. I think this is adjacent, A, adjacent, still on the same dimension. All right, this is just to show the definitions of the size. But what are we looking for? We are looking for ratio of the size when the angle is introduced. What are the ratio? Ratio means two sides or two things comparing. So when I compare AB is a ratio in terms of fraction. A is to B is a ratio. A is to C. A is to B. Okay, B is to C. These are the ratios we can get. So let's identify those ratios and see if we can identify their reciprocal also. Okay, so before we give the names to what the ratios means, let's see if we can create our own ratio. Let's see if I pick, let me put the terms here. B is opposite and C is hypotenuse and A is adjacent. So let me see that. So if I have the opposite, divided by the adjacent. Let me just use 3 letters. That it will give me a ratio. This is a ratio. If I also find opposite divided by the hypotenuse, this is also a ratio. How about picking adjacent and pick opposite, then pick adjacent and pick hypotenuse, or let me pick hypotenuse and pick opposite and pick hypotenuse and pick adjacent. So you can see there are 1, 2, 3, 4, 5, 6. There are 6 ratios in here. Each of the ratio have a specific name, but we are beginning with the basic one. The basic ratios. The basic ratios, sometimes called what? The functions could be, the first one we have the sine. The sine of the given angle. Whatever angle that is indicated. The sine of the angle, which is given as sin of the angle. Since I'm talking about this. If I'm talking about this, it should have been alpha. Then we also have what we call the cosine. Short form as cos of that given angle. Then we have 3 as tangent of the angle, which is the tan of the given angle. Now, by definition, the sine is comparing the opposite side of the triangle to the hypotenuse. So, if I have the opposite and I have the hypotenuse, let me just say O in the beginning as the first letter and I have H. Then, if you take the cosine, which is also by definition, is talking about the ratio of the adjacent to that of the hypotenuse. So, as you have the A and what? H. Then, finally, this is a combination of this and this. But let's say by ratio is also comparing the opposite side with what? The adjacent side. So O and what? A. So if I pick the first one as the first letter S, first letter O, first letter H. If I pick here first letter C, first letter A and H, first letter T, O. So this gives us a mnemonym or acronym, which is called the Secant. So is the sine of the opposite over the hypotenuse. Ka, the cos of the adjacent over the hypotenuse. Tua, the tangent of the opposite over the adjacent. So this is just a mnemonym or acronym that can be used to remember the various ratios. So let's see which ones. Opposite, hypotenuse. So this is taking care of what? The sine. So. Then adjacent over hypotenuse. Adjacent, hypotenuse. So this is also talking about what? The cos. Opposite, adjacent. Opposite, adjacent. So this is give us what? The tan, the sine, the cos. So what is left? We're left with this, this, and this. So if you look at this, you can see that we have opposite over hypotenuse, which is here as reciprocal. If you reciprocate this, meaning 1 divided by this go up to give you this. So this is a reciprocal of sine. If I come here, adjacent, hypotenuse, adjacent, hypotenuse, reciprocal of what? Cos. And this is going to be adjacent, opposite, adjacent, opposite. This is a reciprocal of what? The tan. So now, how do we identify this? I can say that this is the reciprocal of this. So I have this as cotangent. Tangent, right? Which is called the cot. So cot of the angle. Then this area is hypotenuse adjacent. Hypotenuse adjacent, cos. So this is also giving us secant. That is the sec of the angle, reciprocal. Then the final one, where will I write it? Okay, let me just draw a line from here. This is hypotenuse opposite hypotenuse. That is what? Cosecant. Which is CSC of the angle. So now you can see that we have succeeded writing the basic trigonometry ratios and finding their reciprocal. So this is the reciprocal of tan, meaning 1 over tan gave me the cot. Reciprocal, their position change. Then secant, which is also moving to cot. You can see here, adjacent hypotenuse. So 1 over cos give you secant. Then in the case of this, which is the sine, which is cosecant. So cosecant is going to be 1 over what? Sine. All this is just showing the reciprocal of the basic one. Remember, you'll be dealing more of the basic ratios or the basic functions. When I mention basic ratios, your mind goes into the sine, the cos, and the tangent. Then they are reciprocal, as you can see by these ratios, give us what we call the reciprocal of the basic one, making in total 6 trigonometric functions. I guess this is clear. All right, the video is getting a little bit longer, 23 minutes or so. So we need to end this episode here as episode 1. We talk about the introduction or the concept of trigonometry. Then the next episode, as episode 2, we pick how we can use these ratios in solving questions on triangles based on the size or the angles. I guess you will not miss that. Like the video, share if you find it educative. If you find this educative, don't hesitate to share with your colleagues to also benefit from it. Don't hesitate to like and subscribe to the channel, both on Facebook, YouTube, or TikTok. Then leave a comment. Even just a full stop, a comment, just write something for me to know you have watched and appreciate what is here.